Alright, so what I'm going to attempt to do here is show you how to use the build setup software for the SLS machine, for the Sinterstation 2500 Plus. Bear in mind that it is a very old system. The computer itself is very old, and so the software is very slow. If you have a lot of complex model, or if you have a lot of models, it's going to be very laggy, and if you have even just one complex model, it will also be laggy and hard for the system to catch up. So the first thing you need to do is go into the C drive. I don't know if you can see that here, but you go to the C drive, and then you go to the DTM folder. Under DTM is a geometry folder, and under here you will find a folder called samples, and in this folder you'll find one called test geom, which stands for test geometry. So you'll go here, and then you can see all the files in that folder populate up here. So now we're going to look for a file called heat barrier. It's about in the middle of this section. You can kind of see in the top right window a preview of the file. But what we can do is we can double click or we can drag it in. I prefer to just double click as it places it in the center. Now, as you might be able to tell, there's actually a barrier, and this part is too big for this barrier. This is kind of like a thermal barrier that tell you not to print into. So what we need to do is we need to scale this part so that it's properly sized. So we'll click it with the left click, then we will right click it, and as you can see, there's these options that pop up. We'll want to hit the resize and mirror. We will scroll over it, hover over it, and go to basic. So we click on basic, and we have the option to scale in X, Y, and Z. We want to scale X and Y at 0.95 and leave Z at 1. So we're going to type 0.95 for both X and Y, and then we hit apply. So now it's been resized at that. So now if you were to actually go back in and hit resize and mirror, you hit basic, it will show you a value of 1 at X and Y as well as Z. This does not mean that it hasn't been resized. This just means that this is now the scale value of the part. So don't be confused by that after you've already resized it. Don't continue to resize it. But you might be able to see there's a really thin red line out here, and we are now within that border, so we're fine. The next thing I'm going to do is I'm just going to grab a random file. Let's say we're going to take this file. I'm going to double click it. It's going to be imported. And give it a second. All right. So the file is now placed down here. And what we can do is we can move that file around. It's actually in a really good position, but sometimes it can be like placed floating high, and you'll have to click the part and drag it around and bring it back here. Now, if you click and drag in this way, chances are you'll end up moving it in an axis that you don't mean to move it in. It's not super intuitive. So I'm going to hit Control Z. Up in this taskbar, you have a bunch of different rotation and view angles. So I'm going to go to the top view right here, and you can see that I'm centered in the middle, which is totally fine. I'm going to go from let's go from a different side view, where you can see more of the part. And sometimes you have to use the scroll bar on the right side to actually see the part. But you can see it is offset off the build plate here, which is good. I'm going to drag it a little closer, just because the less height you have, the less layers you have. Each layer is 4/1000ths of an inch. So every time that you move this up just a little bit, you're adding another layer that has to be added to the build. Keep in mind that you will run collision detection. You don't want to get too close because it will reject the part. Another thing to note is that if you're going to have any sort of moving geometry, such as an assembly that's printed in place, you will want at least 12/1000ths of an inch in between layers. So this will ideally create 3 layers of space between the 2 parts that you have, 2 components in your assembly. You still will want to add maybe a little bit more buffer room for that. All right, so our part has now been added in the way that we want. We'll check the top view again and the ISO view, and it looks good. So next thing I'm going to do is I'm going to do collision detection. There's a little button up here that is literally a car crashing. That is the collision detection button. You can click that, or you can click collision in this tab right here. But I'm going to click the car. Leave the part with tolerance, part-to-part tolerance of 5/1000 of an inch, and part-to-piston tolerance of 10/1000 of an inch. Keep all parts versus all parts rather than selected parts, and we'll hit OK. It says no collision was detected. That is good. Sometimes it will reject it. So just to test, if I were to go to the side view and I click on the part and I drag it so it's actually in line with that and it's colliding, we'll hit collision detection and it'll throw an error and it'll tell us actually where the collision is. So we hit highlight collision and it will tell us oh, right here these parts are colliding, which it's really the whole part in the plane is colliding, but it's basically telling you where the collision is happening. All right, you can also hide non-colliding parts, but we only have 2 parts in here. So I'm going to go back, I'm going to Control Z that move, try collision detection again, check it, we're good. So we're going to move on. All right, so we've done collision detection. Now we can save the file. First, don't hit save and verify because it's possible that the file you have, you're overwriting an old build file, and that's not good because we want to rename the build file as the day's date. So we're going to go to Save As. We're going to type in today's date of, today is 10.13.2020, and it's a .bpf file. We're going to save. I've already tested this one time, so it's actually going to overwrite. And it won't let us do anything until we verify the file. So now that we've saved it, we need to go back here to File and then Verify All. So we'll hit Verify All. And we're now verified. And now that everything's been verified, we can do a time estimate. So leave the sampling frequency at 11 layers. That's fine. Hit OK. Now it'll tell you how long this print will take. It says here 3 hours and 2 minutes. It will definitely be longer than that. This is just the build time, not the heat up time and the cool down time. Hit OK. Now this next slide is very, very important. Make sure you write these numbers down. It tells us that we need 1.018 inches of powder. It also tells us that the required piston position is 16.982 inches. What this means is that this is the position that your feeder piston should be set to. The way that we actually make this, we build in a factor of safety, we build in a bit of a buffer, is we take that number, we round it down to the nearest tenth, and then subtract another tenth. So we'll take 16.982, we'll round down to 16.9, and then we'll take another tenth off, so 16.8. So make sure you write these numbers down, so it'll end up being 16.8 is the value that you'll set in your the piston feeder. All right, I think in the example that I used previously, it was 16.4, which is what you'll see me use when using the build software, or the Sinter software, excuse me, to raise the pistons and lower the pistons. I think I set it to 16.4. All right, so yeah, make sure you have this information down, hit OK. And you are now done with the build setup software. The part has been saved and you're good to go. You can also check the informations tab to check that you are using the correct powder, the number of parts you have. You can also check the warm-up height, which is set to 1/2 inch right now. The build height, which is 0.303 inches, 0.303 inches, excuse me. The cool-down height of 100 thousandths, and then the powder needed, as well as the max feed position required. It gives you those 3 important values. It gives in this table too. So if you forget, you can go back into here and you can get those values. But that's basically it for build software. So build software or build setup is located here on the left side, and then you can only run one at a time. Oops. All right, cool. So then we'll go into Sinter.